All right, so we're on day 17, and if you've been reading your book, you probably have already read this, and this is actually pretty important up here in this first little statement. When a distribution is skewed, the median and IQR are the best ways to describe the center and spread. When the distribution is skewed left, skewed right, okay, when it's a lot of data on one end, a little bit of data on the other, the median and IQR are the best way to describe the center and spread. Because median and IQR are the only really resistant measures. Okay, but when a distribution is roughly symmetric, there are other things that we can use to describe the center and spread. And actually, these are the things that guide most of the rest of the statistical calculations and testing that we do for the rest of the year. Most statistical things are based on the mean. To describe the center, we can use what's called the sample mean. And the sample mean, you probably know it as the average, but you want to get used to calling it the mean and the sample mean. And to find it, you simply add up all the observations and divide by the sample size. So this is the formula that you actually already know. Okay? This symbol, X bar, which is pronounced X bar, is the sample mean. Okay? That is the notation or the letter we use to represent the sample mean. Just like, you know, way back in algebra, what letter represents slope? M, okay? So M might not be a letter you would think of when you think of slope, but M represents slope, and you know that, and I'm telling you that X bar represents the sample mean. And to find the sample mean, don't you add up? If I wanted to find the average test score in my stats class for the chapter 12 and 13 test, wouldn't I add up all the scores and divide by how many scores I added up, right? So the sample size is the number of observations, which is referred to as N. We've talked about that before. The sample size, the number of observations, the number of pieces of data is N, always. So see how you're dividing by N? Okay. Now this looks confusing. All this means, this is the capital Greek letter sigma, which means add up all of the observations. That's all this means. This is telling you in very short terms, add up all of the observations. That's all that means. Okay? Is it important that you know this formula? Yes. Because when it comes time for the AP test, you're going to be given like 2 pages, front and back each, of formulas that you can use on the AP test. And you need to be able to recognize the formulas. And they're not in the terms that you like them to be, they're in the terms that they want them. So this is the formula for adding up all the x's and dividing by how many there were. All right, so now notation. Notation means the way we write something. In our book, they use y bar or y to represent the observations. So the formula for sample mean in your book will look like y bar equals the sum of all the y's divided by n. Okay, we aren't going to use that. Okay, I don't know why the author of this book, it's one of the top 5 books for teaching AP stats, but they thought that y would be a good letter to use for some reason for observations. Okay, we're going to use x because that's more consistent with most of the rest of the statistical world. Our book isn't wrong, they just decided to use that letter. Okay, it's all right. All the formulas would be the same as the ones I give you, except they have y's and we have x's. All right, tells you how to say it. We do actually find y bar, which would mean the average of the y values. When we have linear regression that deals with ordered pairs rather than just single data, we'll have y bar. So that's why we use x bar most of the time. Okay, it's called a sample mean since it's computed from the observations in a sample. And this is very important. If we had conducted a census and had all the members of the population, we would use this mu represents the population. Well, it tells you the population or the true average. You rarely have a census. You rarely have all the data. You just have sample data most of the time. So we are always going to use X bar to estimate the mu, the actual population mean. It tells you about the sample size. All right, it says graphically, the mean of a distribution is located at the balancing point of the distribution. Remember we talked about balancing point of the distribution? Whether it's a dot plot or a histogram or even a stem and leaf plot, did we talk about the balancing point, putting your finger along a place and balancing the graph? Yeah. Okay, that's the balancing point. The mean represents the balancing point of a distribution, okay? And the mean balances the deviations from the mean. What does deviation mean? Louder, I didn't hear that.
No.
Deviation. What does to deviate mean? Different, okay. Okay, the differences from the mean. How far away the things are from the mean. All right? So, we are going to look at a little dot plot here. Okay, so here's my dot plot. And on my dot plot, I'm going to put some numbers, and we're going to find the mean of these numbers. Okay, so here's my dot plot. Here's my data. 1, 2, 3, 6, and 8. Those are my observations. And I would like you to find the mean of that data for me. X bar is the sum of all the x's divided by how many there are. You will definitely want your graphing calculators out today. They're very crucial today, especially towards the end when I show you how to do all kinds of really wonderful things with your calculator.
So, 20 divided by 5.
20 divided by 5? That would be 4. So the mean is 4. The mean of this data is 4. All right? So the mean of this data is 4. And I just told you that the mean balances out the deviations. The mean is the number that balances the deviations from the mean. So we're going to look at this. Pay attention. Okay, how far is this data value deviated from the mean?
1.
Okay, 1 above or below? So -1. Yes, -1. So 3 is -1, 2 is -2, and 1 is -3. Okay, and 6 is, I forgot to mark there. 6 is +2 and 8 is +4. Okay, so how many deviations, total deviations, are there below the mean?
3.
Well, yeah, there's 3, but how far are they total from the mean? -6. 3, 2, and 1, 6, -6. The 2 deviations above the mean are how far above total? 6. So describe the deviations below the mean. Their sum is 6 below, -6, and the deviations above the mean are 6. The mean balances out how far away the observations are. And it's a very simple calculation. Add up the numbers, divide by how many there are. But that's what it does. And some mathematician decided to start looking at that. Well, how far away are these observations from the mean? And is that important? Okay, because mean is a measure of center. Okay, so mean is a measure of center. All right? And we also are looking for a similar measure of spread. And so these deviations are going to help us come up with that measure of spread. But first we have to answer the question, is the mean a resistant measure of center? How is it affected by outliers and skewness? All right, so we can do that real quick. What if I change What if I change 8 to 15? What's going to be the new mean? I'm changing the dot of 8 into 15. Well, that was too far. What did I just do? Did I create an outlier?
Yeah.
Okay. Remember how when we found the median, we were answering the question whether it was a resistant measure, we changed like 38 to 388 or something like that?
Increases 5.4.
Okay, so now the mean is 5.4. So did the mean change?
Yes.
So is the mean a it changed because of an outlier. Is the mean a resistant measure? No. The mean is not a resistant measure. All right, what was the resistant measure? We only had 2 of them so far.
Wasn't it the range? No, not the range, it was, I forgot.
All right, I'll let you think of them. All right, another way to measure the spread of a distribution is to estimate the average deviation from the mean. The average deviation, how far away on average are the observations from the mean, is called the standard deviation. You will not fully understand the standard deviation unless you read the book and actually think about it when you read. Try to process the information, not just like look at the words and say that I'm done reading now because I looked at all the words on this page for a really long time. Okay, so the standard deviation is now what we want to calculate. So the standard deviation of these numbers, what we're going to do, actually we're not going to find these numbers, we're going to do the next page. Anyone know the resistant measures yet? Very good. The median and the IQR are resistant measures. You're going to have to know that for the test. I guarantee it. Yeah. The mean is not a resistant measure. All right, so now what we're going to do is we are going to find and interpret the standard deviation of the following distribution of home runs. Now, standard deviation is the average distance from the mean. What is the average distance? On average, how far is an observation from the mean? Okay, so we are going to do this. This is a very easy thing. Our calculator is going to help us a little bit, but not so much. For the most part, we're going to do this all on our own. So the standard deviation, to find it, I need to make like a little chart here, and I'm going to put all of these observations in it. So this is exactly what you should be doing with that big blank space that you have in your notes, just like I'm doing. And then the next thing I need to do is calculate my mean. So to find my x bar, I'm just going to use my calculator. I'm going to add up 1 plus 13 plus 11 plus 11.
You have 11 3 times, so
Yeah, you need to change my 11 to a 1.
No, I have 1. Oh,
yeah, very bottom, you have number 11.
oh, what is it?
That's a 1.
The 1. It goes
Yours
1,
is a
13.
1?
The fourth one's 1.
Goes 1, 13, 11, 1, 5, 9, 6, 5, 8.
Okay. So what do you, yeah, you should get 70. So they add up to 70, and how many observations are there? 10. So what is the mean?
7.
7. All right, so on that little if we were to make a dot plot of these, we actually measured the distances. What math operation could we do to find those distances? It's way easier than that. It's one simple math operation to find how far away two numbers are from each other. Subtract them. Okay, hold on. We're going to have to take a little